For today's webinar, I'm going to be talking about how to strategically communicate with numerical data in order to tell a more effective climate change story through a frame element called Social Math. Social Math supports the language-based framing choices with numbers that advance and strengthen the overall communication strategy. Translates data to a more comprehensible and compelling terms by making a comparison to a familiar domain on a relatable scale. Broadens understanding of the issue and leads the public to think constructively about solutions. In this webinar, we'll be learning why unframed numerical data are not helpful for communicating climate change, how social math works, some of the traps you should avoid when framing numbers, and how to use the frame element of social math for communicating about climate change. By now, you know that it's unwise to introduce a new idea without framing it. Numerical data works just like any other information that we want to share. We often find that numerical data is presented without interpretation, especially when it comes to translating scientific findings. Here's a typical example of how scientific data is presented to explain climate trends. Take a few seconds to think about what this graph means. This graph says something important about the relationship between carbon dioxide, temperature, and sea level rise. But without the scientific team who generated the data present to walk me through this graph in baby steps, all I can make out is that it looks like during the Little Ice Age 10 to 20,000 years ago, sea levels were lower, and they've remained fairly steady over the past 1,000 years or so. Without an advanced understanding of the science, this graph can be interpreted in many ways. Those steady-ish lines in the upper right-hand corner of the graph make it seem like we've got nothing to worry about. I don't see any precipitous drop-offs or spikes in the plot lines. Without interpretation, which in this case probably means presenting the data in another format, this data loses its potential impact to help people understand what we need to know about sea level rise in order to make informed decisions about climate change. Unfortunately, this is where a lot of numerical data ends up when it's used as part of communications about climate change, as an uninterpreted add-on. The idea is that people will see the data and how it clearly illustrates the point being made. This is how numerical data are normally used in communications. We start with some data, and it's all the better if the first ones are about alarming statistics. It's as if the underlying question motivating the use of numbers is, can't you understand why this is an untenable situation? Versus engaging the public and elevating the discourse, asking instead, do you see how we might solve the problem? Then we add some more evidence, because we always have more data, and maybe a graph. This all leads to the recommendations for changes or solutions. This formula isn't as effective as we might hope. It's just listing. It doesn't shift cognition. In many cases, it can backfire and actually reinforce dominant ways of thinking, even though you have this compelling data that shows the status quo thinking is limited in some way. Let me make this more concrete. Climate change advocates are often drawn to throwing out data like this as compelling points. But really, what is so compelling about a 1.3 degree change in temperature? The public just thinks, compared to what? In this case, what's a degree here and there? Here's another example of how climate communicators often use data. We often use data to try and explain how much carbon dioxide has been emitted since the beginning of the Industrial Revolution. But without some careful framing, that runs the risk of falling into the cultural models that change is natural and you shouldn't do anything to stop it. Once this happens, the point you're making never registers. Here's another example of a communicator trying to explain how much carbon is absorbed by the oceans. But without a larger context that compares what is normal versus what is excessive, the public may think that this is actually good for the planet because it helps the planet stay cooler. Numbers, like all information we encounter, activate and call up prior associations and assumptions. That is, they go into the swamp just like any other ways of communicating. They don't have the magical prove my point powers that we often imbue them with. But numbers do have their uses. They can help us to illustrate trends and not just isolated events, showing that the problem is a collective issue and not just an individual problem. They can help people to understand the full scope of an issue, or simply help us to make more informed decisions about what to focus on and why. So don't get rid of numbers. Use them carefully with the frame element of social math. As you can see by these examples, it is unwise to introduce facts without doing some preventative framing. If you don't frame the issue carefully, establishing understanding of the underlying causes and mechanisms of the issue, then I can 100% guarantee you that the facts will not be as effective with anyone except existing supporters and those who already understand the issue. For your average visitor who might not fully understand how the issue works, naked numbers are like any other piece of information. If you don't frame it, you run the risk of activating unproductive cultural models. Your choice is to reframe or accept that it's coming pre-framed. We want to frame data so that way people know how to understand and remember numerical data in a way that is meaningful, that supports our communication goals. Part 2. How social math works. Social math is about comparison. X is like a certain number of Y. Let's take a look at an example. The tobacco industry spends $12.5 billion a year promoting smoking. How much does this equate to? Why is this important? Compared to what? Instead, can you imagine what $12.5 billion looks like? Me neither. But when I compared it in terms of what the industry spends in a week to what the government spends in a year, this figure becomes much more understandable. And it's no accident that I drew a relationship between the money promoting smoking and preventing smoking, which helps the public to understand the relevant factors at work on this issue. Social math works sort of like a currency converter when in a foreign country. Remember that most people don't think about most of the issues most of the time. You have to assume when planning your communication that the audience knows virtually nothing about the topic. So providing the context for interpreting the data is really important. And even if you know you're speaking to a well-informed audience, giving them a really sticky way to understand the data increases the chance that they'll pick that up and repeat it. We're all familiar with temperature, but to the average non-climate scientist, rates of change, which is what this stat is trying to get at, are a very unfamiliar concept. A challenge in framing temperature increase is that people's direct experiences with small variations in temperature through daily weather make the scale and consequences of average global temperatures hard to think. We know what 1 degree feels like on the scale of a day in our local town or city. It's no big deal, right? Wrong. What we need to do here is select a comparative concept familiar enough to help our audience understand just how significant a 1 degree change over a 14-year time span really is. Here, we've created a relationship between something unfamiliar, that's temperature change between years, to something more familiar, breaking a world record by 2 feet. This helps the public understand the rarity of something like this occurring during this span of time. You would want to follow up to make sure that you're not leaving the impression that warmer is better. I might follow this up with a sentence that says, if nothing is done to halt the warming process, the planet we leave our children with is going to be hotter with more extreme weather. Social math makes something that's kind of fuzzy to see, like this close-up on the left, into a clear picture. For strategic framers, a clear picture is one in which the problem is explained in such a way that leads to thinking about appropriate solutions. Let's look at an example with abstract figures. This is an example of using unframed data to build support for an organization that works to enlarge public land in urban areas. Does this work for you? Do you understand just how much land this equates to? Do you get an understanding of the benefits here? Here's a better comparison. This reframed example breaks down a large number into the more familiar unit of a soccer field. The example chosen of a soccer field works with the organization's overall goal of preserving and expanding public spaces. It gets the audience thinking in the direction of the desired solutions. Social math is not a standalone framing element. it's always combined with other frame elements, including values, explanatory metaphors, and explanatory chains to support a well-framed message that broadens public understanding of the issue and leads your audience to think constructively about solutions. In this example, social math is used to help people to conceptualize how much spawning ground the bluefin will lose as a result of climate change. But something is still missing in the communications. Without knowing what causes the warming and how the warming impacts bluefin spawning habitats, it's unclear how to intervene to prevent this from happening. This data calls for some more frame elements. When you bring frame elements together, the result is very powerful. This explanatory chain clarifies how tuna are losing their habitat. Do you see how I used the touchpoint animal, the bluefin, to introduce the issue of climate change in a pragmatic way? When we combine our example of social math with the heat-trapping blanket, our audiences are equipped with the information they need to solve the issue for tuna and for all of us. They understand the scope of the problem, how the problem works, and how to fix it. If I were to continue this bit of interpretation, I might talk about the consequences of losing species that are at the top of the food chain, or the impacts of the loss of tuna for humans. To recap, social math compares the size of two things, creates a relationship between familiar and unfamiliar concepts, makes appropriate solutions visible, and does not stand alone. Part 3. Watch out for climate data traps. Remember, strategic framing is the process of making intentional choices about what to emphasize and what to leave unsaid. There are some common ways that environmental communicators use data that aren't productive in terms of building public understanding of climate and ocean science. These all appear logical at first glance, but social science research suggests that they may actually do more harm than good. They are communication traps. Traps are habits of a field that seem to be eminently plausible ways of talking about an issue, but that upon further analysis turn out to undermine the communicator's intention. Let's take a look at 5 common traps that communicators often fall into when they are using data to try and build understanding of climate change. Many people use statistics to stimulate crisis thinking. When looking at these visuals, what do you see? What do you think is the takeaway message conveyed by all this red? The message is extreme. By 2050, nearly half the U.S. will face extreme water shortages. That is 10 times worse than the drought conditions experienced during the Dust Bowl, which has been identified as the most extreme natural event in 350 years. This is meant to present the data in a meaningful way by comparing it to something that may be more familiar, but it ends up falling into the crisis trap instead. Simply converting numbers doesn't make social math. Here, we have 2 comparisons of a rate of change for temperature increase. This example compares one statistic to a similar kind of statistic. Neither set of numbers has been compared to anything meaningful and concrete that we can relate to. To top it off, this statement is pretty swampy. See if you can think of the cultural models this statement triggers. Did this make you think of the corner of the swamp about nature? Yep, this statement can easily get a lot of people thinking along the lines of, change is natural, we couldn't or shouldn't stop it, especially if they don't understand how rates of change work. And most people don't. Climate communicators often think that if they help the public conceptualize the volume or weight of carbon emitted into the atmosphere or absorbed by the ocean, it will make the size and scope of the problem more obvious. Since the Industrial Revolution, humans have added nearly 1.5 trillion metric tons to the atmosphere. The ocean have absorbed about 1/3 of that amount, some 500 billion metric tons. That's equivalent to 500 billion VW Beetles by weight unloaded into the oceans. The problem with this is that the work we would want this information to do, to get people to understand that carbon is causing problems, is better accomplished by the heat-trapping blanket. Instead, It's better to find stats to help communicate the extent to which ecosystems, animals, and humans may be affected by climate change. This example starts with a data point about how the impacts of climate change are affecting the size of tuna, but the swampy comparison takes the data in a wrong direction. This statement is attempting to get people to care about the impacts of climate change on tuna populations. It's attempting to explain exactly how much money was spent on one fish by comparing it to feeding a stadium full of people. But this is the wrong comparison if you want people to understand how climate change impacts this species and what they can do to address the root cause of changes in the ocean. Comparing the market price of tuna to the number of people who can be fed takes us right into the consumerism domain of the swamp. Your audience might start thinking about the issue using the cultural models, eat it while you can, or even jobs versus environment, neither of which is going to lead them to a logical solution. This is a swampy statistic. Mother Earth metaphors are so common in climate change communications that they get their own trap. Mother Earth is a very unproductive cultural model when it comes to thinking about Earth systems. Once people are thinking of the planet's ecosystem as Mother Earth, all sorts of unproductive entailments come along with it. Earth will heal itself. Mother Nature will never fail us. Mother Nature knows best. A strategy we've seen pretty common use of is to make an analogy of a person running a fever, because this is a domain in which people know that a degree or two can make a big difference. Here's a beautifully written example from a recent novel. Living systems are very sensitive to very small changes, De La Robbia. Think of a child's temperature elevated by 2 degrees. Would you call it normal? 100, that's a low-grade fever, she said. Aches and chills. De La Robbia disliked the thermometer she kept in her makeup drawer, the treacherously slim glass pipe, and its regime of wakeful nights. And if the temperature keeps going up, he asked. More? At 103, I'd head for the emergency room. That's 4.5 degrees. More than that? Don't make me think about it. If you are looking at this and disagreeing with me thinking, this really makes small temperature increases easier to understand, you're only half right. Yes, it does make it easy to understand, but there's more going on here. The message is crisis-y, so those who already care might still care, but it's also swampy. When we start to think about the planet as a person, there are many unproductive things that come with it. The most dangerous being that Mother Earth can take care of herself. Or, people thinking of global temperature increase as a fever can also easily reason that there's a simple fix. Take 2 aspirin and call me in the morning. So, there may be an increase in understanding about what's going on, but not in civic engagement with the issue or people's ability to think about the appropriate solutions. And we want all of our communications to bring along everybody all of the time. So, to recap, now that I've told you how not to use social math for climate change interpretation, let's focus on how to use this frame element. Climate data traps. Crisis makes the problem too big to fix. Numerical equivalency increases confusion. Carbon comparisons take the focus off how climate change happens. Swampy selections reinforce unproductive ways of thinking about the environment. Mother Earth metaphors induce apathy. Part 4, Framing with Social Math. Here's how to do it. You want to begin by selecting a data point that reinforces the message you want to make. This may sound obvious, but communicators often select a data point that doesn't have a whole lot to do with the point of the message. Starting with this step might actually lead you to realize you don't need data. That's fine. But if you decide that there is data that will enhance the communication, then you want to select relevant data that enables people to understand the meaning of a scientific concept or trend related to climate change and its impacts on oceans, or understand how active citizenship might make a meaningful difference for community solutions. The data you choose to make more powerful through social math should help the audience to better understand the scope and scale of the problem or efficacy of the solution. This slide lists some useful areas for including social math in climate change interpretation. You could talk about habitat loss, species decline, predicted damage to human communities, or how much carbon emissions could be reduced through a particular solution. Let's check in to see if this is making sense. Imagine that you're choosing data to strengthen a communication. Take a look at the following data points. Which of these do you think would best enhance climate change interpretation with a social math example? I'll give you a few seconds to think it over. The correct answer is C. Let me walk you through these. A is not right. Seems like it might help explain how climate change works, but it's not the best choice. First, the explanatory metaphor of heat-trapping blanket has been designed and tested to help people quickly understand and remember how climate change works and where the solutions to the problem lie. You might be thinking that a social math example about how much excess carbon dioxide people are emitting might support a heat-trapping blanket statement, but it won't. Remember, social math works by comparing unfamiliar to familiar things. The amount of excess carbon dioxide emissions is so large that it could only be compared to something else very large. For example, in 2011, carbon dioxide emissions reached an all-time high of 34 billion tons. If you were to compare that to something people can relate to, emissions put out by a family car, for example, you would have to multiply that number so many times that it would render itself unrelatable. B seems like it might be a good data point for talking about the impacts of climate change on oceans and ocean critters. But if you think about it, this data wouldn't really support understanding of the issue at all. By highlighting the amount of excess carbon dioxide absorbed by plankton, you're setting up your visitors down a swampy path. They're likely to assume that plankton is absorbing excess carbon dioxide, then there's no problem. C is your best bet. It's a relatable number and it will let you open up a discussion of solutions. Your first step is to choose the data wisely. The second is to choose the analogy just as thoughtfully. There are lots of comparisons that could be made. The best comparisons are familiar, on a relatable human scale, and memorable. It's important to carefully choose a concrete comparison that the average visitor will find familiar. Choose analogies that fall within people's everyday action scenarios, things we hear about every day in our shared culture. You have to assume that when planning your communication that the audience knows virtually nothing about the topic. Give visitors a familiar way to understand the data so that they'll remember it and repeat it. Keep it on a relatable human scale. The math should work out so that the units or numbers aren't really large. If you do the math and the number comes out to be in the millions or trillions, consider an alternative. Sometimes this can't be helped, but sometimes it can, by choosing a comparison object that's bigger. Finally, work for something that's memorable. You want your audience to repeat the statistic. This is part of the value of social math. This quality is somewhat subjective, so you have to use your judgment. But if you come up with something surprising or slightly unusual, but not totally out there, then it's what you're going for. Let's check in on how well you're understanding these ideas. Imagine you've decided to frame some data on predictions of sea level rise. Scientists predict it will rise by 3 feet by the end of the century, sort of thing. Your next step is to choose a direction for that analogy. Take a look at the following analogies that you could pursue. Which of these do you think would make the best comparison for the data selected? I'll give you a few seconds to think it over. Let's go through these. B is correct. Here's why. A talks about predictions for other cities that might be a comparison, but it's not a true analogy to what you were expressing the original data in terms of something else. Listing other data points is just giving more data. C at the bottom is wrong too. This is one of those analogies that's good in some ways, but ends up falling apart when you do the math. It's good because it's familiar, because everyone can imagine how much water fits in a bathtub, and it's memorable. But the sheer amount of bathtubs it would take ends up at an unrelatable scale. It would be something like 8 million bathtubs, and the volume of water isn't really what we want people to focus on. The more meaningful information is how and why the changes will affect ecosystems and habitats, including human habitats. We want to use social math to illuminate trends and mechanisms, not just wow people with big numbers. So B is the best kind of analogy to pursue for this data. C is wrong too. This is one of those analogies that's good in some ways, but ends up falling apart when you do the math. It's good because it's familiar. Everyone can imagine how much water fits in a bathtub, and it's memorable. But the sheer amount of bathtubs it would take would end up at an unrelatable scale. It would be something like 8 million bathtubs. And the volume of water isn't really what we want to focus people on. The more meaningful information is how and why the changes will affect ecosystems and habitats, including human habitats. We want to use social math to illuminate trends and mechanisms, not just wow people with big numbers. Watch out for data traps and swampy comparisons. The social math data point or comparisons you choose should not cue traps or unproductive parts of the swamp. Common data traps include crisis, numerical equivalency, carbon comparisons, swampy selections, and Mother Earth metaphors. So, you have data worth talking about, and you have an analogy that seems as if it will be meaningful for people. The next step is to double check that the data selected and its comparisons do not cue up unproductive ways of thinking. Here, strategic communicators refer to research on cultural models and the implications of these shared patterns of thought. Mind the swamp. There are gators in there that will eat your message. Think about the analogy with respect to what else you know about public thinking on the issue. For instance, we know that the public defaults very easily to recycling as the best solution to address climate change. So, no comparisons to the number of water bottles saved. We know that the public thinks of the ocean as a bottomless grocery store. So, no comparisons to the food domain. And keep watching out for traps, plausible ways of framing an issue that, in light of the social science research, turns out to undermine the communications goal. Let's try to distinguish between swampy and strategic directions. Take a look at the following data points. Which of these is not a swampy selection? I'll give you a few seconds to read these and think them over. The correct answer is B. Let's think about why. A is a swampy selection. It cues up the eat it while you can cultural model, and depending on how it's executed, it could also cue up crisis thinking. C at the bottom is also a swampy selection. By highlighting how much of the ocean is protected in marine reserves, you run the risk of cueing the cultural models that work as arguments against marine protection areas, that any damage to the oceans are a drop in the bucket, and that the oceans are vast and invincible. It can also cue up crisis, that not enough is being done fast enough. The only one here that doesn't lead straight into swampy thinking is B. It's a rate of change, which is exactly the kind of data we want to help people understand so that they're motivated to address climate change. The analogy here would be important, of course. It could easily fall into the comparison data trap by simply comparing one rate of change to another. But if you choose an analogy such as something moving way too fast, like a child growing to full maturity in a week, then it could bring the point home for people. Social math does not stand alone. Always incorporate social math into a larger message to illustrate the scale or effects of a problem or solution. Social math should support the frame elements value, explanatory metaphor, explanatory chain, and solutions. Take a look at the following types of social math examples. Which of these best supports an appropriate climate change solution? A is the best choice. Let's look at why. For A, by comparing the impacts of an unfamiliar topic, acidification, to a familiar impact on a local keystone species, This analogy opens up the opportunity to follow up with an explanatory chain that makes a connection between excess carbon dioxide and acidification. The solution is to reduce carbon dioxide emissions. For B, I would be concerned that the analogy wouldn't lead people to think about an appropriate solution. People might easily misunderstand what you're saying about the cause of global warming, taking attention away from excess carbon dioxide emissions to the burning of rainforest for grazing land. And the analogy is really banking on the fact that people already know about rainforest clearing. This is a familiar issue for those who pay attention to environmental issues, but in designing communications for the general public, keep in mind that most people don't think about most issues most of the time. Did you pick C? C seems like it might lead to the right solutions because of its focus on reducing carbon dioxide emissions, but it takes attention away from community level or other appropriately scaled solutions to swampy consumerism thinking by turning the focus to what can be purchased. We know from the literature in environmental psychology that this kind of proposition leads to individual scale solutions thinking, as in, if I reduce my personal carbon footprint, I'll save enough in utility bills to purchase a designer handbag. It also leads to distrust in solutions at the community level, as in, why should I sacrifice driving to work to invest in our electric shared community vehicle program when I know my neighbors won't? Because what we know about how climate change works is driven by evidence in the form of numbers and statistics, you should not be afraid of including this kind of data into your communications about climate change. But this doesn't mean throw in any old interesting new data point or statistic that you come across. Remember, a strategic framework does not provide data for data's sake. You're not cramming your communication full of statistics. You are really looking for those moments where an appeal to something quantitative will enhance your message. Just like every other frame element, social math takes practice to perfect, but once you get it, it's a powerful tool for science translation. Let's take a look at this checklist for framing with social math to sum up this webinar. You want to begin by selecting a data point that reinforces the message you want to make. Choose a data point that supports your climate change interpretation, and then use social math to reinforce your main message. Use social math to create a relationship between unfamiliar data with a familiar concept. You should always select your comparisons wisely. Whatever source domain you draw from, you don't want to activate a trap or unproductive models from the swamp. And you should always use other frame elements in conjunction with social math. Social math should always support the main goal of your strategically framed communications. It is not a standalone frame element. Thanks for joining me on today's webinar.